So this is just a snapshot slide for the, it's not the web page.
Oh, okay.
So if you're introducing the session, just don't press down, you'll be into my list.
Yeah, right. So I'll let you do that. I'm not going to touch anything. Well, good morning. Hope everybody had a good time last night. I left before everybody left at the bar, so who knows what happened after I left. But I'm all sure we had a good time. It was good food, and so welcome back. Had some good comments about the session yesterday. Positive, areas to improve, always good. We'll keep working on that. So we have completed 3 sessions. You remember yesterday we had session 1 was foundation, session 2 data representation analytics, session 3 was ripe trends. We heard some really good stuff. So a lot of technical detail kind of yesterday. And so now today we turn to applications. You know, what's the value? What's the outcomes? Why do we want to do this? Not just because we can, but because it actually produces some results that are useful in a variety of domains. And so that begins session 4. Jeremy will step up here in a minute and lead that session. And there'll be a panel, there'll be a breakout group around different application areas. Lunch the same as yesterday, Ed, correct? Kind of the same scheme. All right. We'll try to be done at 5 till 12 and get over there before that rush. But yeah. Then after lunch, we've got 2 things. One is a session about next steps. So having heard all this and the good things that could be done, what are the things that we should do to make it happen? And so we've got some excellent discussions and presentations about that. And then the end of the day will be the reports from the rapporteurs about what did we hear. And so again, if they're not saying what you heard, please let them know, because they'll be the basis of the report that comes out of here. And one other item of business, if you will. People that have presented anything, if you want it to be on the public page, send it to me and I will get it on the public page. I'm encouraging you to send that. But if you've got issues about sharing it, I understand. But I would love to be able to put everything that's been presented here up on a public page. So probably as a PDF is probably the easiest way to do it. But if you've got other ways to do it, let's get that material that you guys work so hard on out into the public information. That's my overview of where we're at with the overall workshop. Any questions, comments, how we can do better today? Anything come to mind before I turn it over to our esteemed colleague, who I've known for many years, most notably a trip to Goa, but we won't talk about that. It involved infectious diseases, as I recall. Yeah, right. It was a demonstration about disease spread. We didn't infect anybody or get infected, so let me clear that up right away. So in any case, from the Ordnance Survey, the Chief Scientist, Jeremy Morley.
Thank you, George. That's quite an introduction. So welcome to the second day and to session 4, which turns more towards thinking about kind of applications and application areas for data science and geodata science, whatever that may comprise. So on screen you can see the rough agenda. I think what we'll be doing is going basically straight into the keynote for this session and Wendy's talk. After that, we'll have a comfort break while we kind of reorganize for the panels and so on. So somewhere around 10ish. And then we have a slightly different structure for the discussion groups today, which is apparently in the Google tradition of when you want to think deep, you get out. And so we're going to, to use an OS buzz phrase, we're going to get outside and have some walking groups to for the structured discussion before lunch. Yes, I think that if there's groups that want to stay here and sit, then that is fine. Not everyone necessarily wants to go for a walk, but we're on the edge of some beautiful outdoor areas, I understand. So stretching out, some not indoors, outside spaces. So we'll experiment with that before lunch as well. So we have an interesting cross section of thematic areas to explore today. I'll say a few words as well before the panel too, but I think probably we'll go straight into the first session, the keynote. So could you please welcome Wendy Martinez from the Bureau of Labour Statistics, and excuse us for a moment while we do the knitting to get the right laptop connected. Thank you.
Okay, thank you.
So which was the port?
I think there's only one. So a little story, many years ago, I worked with a bunch of engineers at a Navy lab, and I would always have them, hook my computer up, and this was like the beginning of the internet, and so I'm dating myself, but anyway, they would hook everything up for me, and I got a new computer, and I said, well, go hook it up for me, and they said, no, you have to do it yourself. Oh, and this was before they had, the color-coded plugs and so forth. And so I somehow managed to hook it was like my monitor into the Ethernet, the network, or vice versa or something. And they went, oh no. So then I never had to hook things up. So thank you, Jeremy. All right, let me make sure I don't, spill water everywhere here. Okay, so Ed, can they hear me okay? Where's Ed? Oh, can they hear me okay online? Okay, that was two Eds. All right. Well, first of all, I'm happy to be here today to get us started for session 4 on outcomes. I have to say that I'm pretty intimidated when, now, and especially when George asked me to talk, because I unfortunately do not get the chance to work with geospatial data. And so there's so many of you around here who do and know a lot more about it than I do. But fortunately, I do get to hang around with people who work with geospatial data. And this is through the Federal Committee on Statistical Methodology, or FCSM. They have a geospatial interest group that I've been involved with for many years. And then also the FCSM had a working group that's been focused on how do we deal with data quality issues when we have statistical products that come from integrating multiple data sources together. So for example, data from surveys or say administrative data. And I'm especially grateful to this list of people here because they're the ones who do all the fun work, and they're the ones who gave the applications examples that I'm going to talk about. So I'll just be kind of scratching the surface on these, and I'm sure it's probably okay with the people who know more than I do. And where's George? Oh, there you are, like right in front of me. If it makes sense, maybe we could have seminars, web remote access, events where these folks can explain these applications in more detail. And then, yeah, so we could even do it maybe so it could have international remote access too. Okay, great. All right, so I'm going to try to motivate the discussion that's going to follow my presentation. And the examples I'm going to talk about, I'm going to focus on a couple things. First, that they are products that came about by integrating multiple data sources together. And then also that these are tools that you could use to download the data yourself to use, because I think this is really important to be able to access these data sets. And then I'm going to conclude with some issues that hopefully will kind of inform our discussion. So I'll be talking about 5 applications from these federal agencies. So this is your tax dollars at work, which is good. And the first one is from transportation, and I'm really grateful that Ed Stracco is here, because if you have any questions on this one, you know, Ed can answer them. But I really like this one because it, in my opinion, it really is a true example of an application of machine learning, data science with geospatial data, and integrating multiple data sources together. And the other examples I don't think have, so they don't really have this modeling aspect to it. Although based on the talk I think at the end yesterday about AI at the edge, I guess, he did mention the different types of analysis, and one of them was descriptive. So of course we do have descriptive statistics. So I think the rest of the applications are more in that realm. So this first one, as I said, Bureau of the Transportation Department, and what they did was they integrated information from Waze. How many of you use Waze? I haven't yet, so I guess I need to need to start doing that. But they integrated Waze data with sort of what I guess what I'm calling traditional transportation information. And they had 3 sort of case studies or projects. One was, I'll talk in more detail about it, was they built models to indicate or predict crashes in 4 different states. And then they also did a sort of a similar modeling task for the state of Tennessee, and then also for Bellevue, Washington. So I'm not going to talk about Bellevue, but I do have a slide at the end, sort of in the backup area, but I won't talk about that. So in the first example of integrating the Waze data, this was over 4 states. So it was Virginia, Maryland, Connecticut, and Utah. And I'll just go into these, show the details here, but the overall goal was to see how they could integrate the Waze information with the traditional traffic information, and then see if they could build better predictive models for crashes. So they had data all for 2018. As I said, it was Maryland, Virginia, Connecticut, and Utah. They built separate models for each state. The response variable was, let me get this right, the presence of a police accident report in a specific grid and in some specific hour. So you see here the, oh, is this even on? No, now it is. So here's the list of predictor variables there. They used the count of Waze traffic incidents, information about traffic volume, information about the roadway, socioeconomic data, historical fatal crashes, and they used random forest, which is a machine learning approach. They trained the model on 70% of the data and then tested it on the remaining 30%. So this is where I said this was, in my view, a real application of data science, where we're creating a model, where they were creating a model to do some prediction. And here's the results. They created dashboards in Tableau. And so they have, these are sort of clocks, I guess, for each of the states, and it gives you information about how the model performed in terms of the percent of crashes that were estimated. And what's interesting is you can see that, so it starts at midnight up here and then goes around just like a clock does. But you see for these states, Maryland, Connecticut, and Virginia, sort of in the nighttime hours, overnight, there's only 70% were predicted were estimated of what was actually observed. And whereas in the times where there was commuting, so the commuting hours, you see that there's sort of more crashes were estimated. And I have to point out that the based on stakeholder feedback, they did err on the side of overestimating. So sort of over are, including false positives. All right, and then so it's kind of interesting because the Waze signal is stronger here during commute hours, and so then that's where they tend to overestimate. All right, and I just want to go back here to the map because you can see the different colors here, dark blue and white. So the dark blue is true zeros, where there really was a Waze signal and no police accident or no Waze accident or police report was given. So those were true positives rather than false positives. And the white, so these are true zeros, true negatives. And then the white were true positives where the correct number of crashes were estimated. So I think this shows that, the use of Waze data can give, better information and better models. And that's, I think, evidenced too by this Tennessee case study, where they did a similar approach to do the modeling. And what I found was interesting about this one was that the State Highway Patrol in Tennessee was already mandated to use models to help predict crash propensity, and so then they could better target their patrols. So the Department of Transportation included Waze data, incorporated the Waze data in the models, and they were able to improve the spatial resolution down to 1 square mile, and then also the time to 1 hour. So as I said, the incorporating Waze information improved the ability for planners to make investment decisions and more effectively target patrol areas. So the next one is about disasters. We heard a little bit about this yesterday, but I don't think we heard about this actual application. How many of you heard of On the Map at the Census Bureau? Okay, some of you are. That's good. So this is a web-based mapping application that shows information about where workers are employed and where they live. And it does provide a user interface to go in there, select data, import your own geography or use theirs, download the maps, and more importantly, as I said earlier, download the underlying data. So it's a way to kind of select data and then download it. So this is based on the Longitudinal Employee Household Dynamics survey. This is the documentation page. I will give the slides to you, George, so people have the links and everything. Here's just a screenshot of the tool, but according to the census folks who developed this, some of the emergency management agencies started asking for more, I guess, analytics in the tool because there really weren't any built into the current tool that I'm showing here. So they added some, I guess, smarts to it. I don't know if that's the right word, but by combining information from different data sources. So you see here that they have data from NOAA that gives information about hurricanes and storms and weather. They have information from, I think that's FEMA, about disaster events that are going on. So things like the wildfires here in California. We also get that from Department of Interior and USDA, and then of course socio-economic information from and demographics from Census itself. So they created On the Map for emergency management, and here's an example or just a screenshot of some of the information that you can get from the tool. So again, I don't know that there's a lot of modeling going on here like we have with the example I just showed from the Department of Transportation, but certainly this is a way to describe, what's going on in an area or region, and accounting for disasters or other events. So the next one has to do with public health. This is from the CDC. They have an environmental public health tracking network. And this has data and information on environmental issues and hazards that are going on, the health effects that come about because of those environments and hazards, and then information about the population. They have a similar tool, I guess, to On the Map that allows you to explore the data that they have. And what I was really excited about this this tool, I guess, is that they have data sources from national, state, and local agencies. Is the California person here? Is that you? No? Okay, anyway, somebody yesterday was talking about, she was from the state of California and, have Public Utilities Commission, yeah. So this is, I think this is a tool where such a commission could, access data and information that they could use for better planning and interventions and health interventions and so forth. But the other thing that was really exciting to me about this tool was the fact that it brought together data from different sources, as I just said, but it's standardized. And then once you, kind of create get the data that you want or need for your application or your study, then you could download the data for your own use. So it's another way to kind of get data from these different agencies. So here is the website. I was kind of surprised when I was preparing the slides that it's been there for 10 years. So so take advantage of it. I don't know if they actually have historical data. That would be interesting to find out. But they do have this data explorer. And here is a screenshot of it. And when we had our gig workshop last month, they gave somebody from the CDC gave a presentation on this, and it was really excellent. So that's something, as I said, I could set up for everybody here. So just to say here's a couple examples of how this has been used. And I got these examples from their website. They have an information sheet. One was the state of Minnesota. Back in the early 2000s, they banned smoking indoors largely, for the most part, at public places and workplaces. But I guess in the past couple years or so, there was a movement to rescind or remove those regulations, and some organizations said, well, that's not a good thing, and so they used information from the tracking network to gather evidence on how there's this decreased exposure to secondhand smoke and then the health benefits that resulted from that. So now they've kind of stopped pushing to remove that legislation. And then in California, there was a concern about nitrate contamination in drinking water. So they used, some folks used the tracking tool, the tracking network data to help map the entire water system public water system in California. So it allowed them to identify areas where there's concern for nitrate contamination, and then propose ways that they might fix that. And what was also interesting was, I don't know how they would do this, but they said that this helped them also find out where there might be some unlabeled or unregulated wells. So they might have these like secret wells that were using the water. So I thought that was kind of interesting. And I also wondered, maybe they do have this in the network, but it would be interesting to maybe put some more, maybe create some models for the EPH tracking network to maybe do some surveillance to keep an eye out for bad things that could happen based on the environment that could impact our public health. The next one is agriculture. So one of the speakers yesterday gave an example of hurricane flooding, and how they were kind of determining what were the areas that were affected by the floods. So this is a kind of a similar application. This is from the National Agricultural Statistics Service, or NASS, and they were doing near real-time flood mapping of cropland areas. So here's some pictures of recent hurricanes. And what's one of the common things? What's one thing that's common amongst all these pictures? Right, swirly clouds, right? Clouds. And this was mentioned yesterday. So that's an issue because NASS uses information from remote sensing, which is from optical sensors, and so those are affected by cloud cover and night. So that makes it a little difficult to understand what's happening with floods and cropland. So they turn to SAR, or synthetic aperture radar, because this sensor can gather information or data day and night and through clouds. So these were the two sources of the data. Again, this is another application of data sets being integrated. So they use information or data from the Copernicus Sentinel-1 synthetic aperture radar. Two things I guess I want to point out here. First is that it's free. I really love free data. And so there's a link to it down at the bottom. And then secondly, that it's free within 24 hours. So there's somewhat rapid production or availability of the SAR data. And then NASS itself has provides data on crops in the U.S. It's georeferenced, and they have land cover data sets. As I said, though, this is from optical sensors, so this is from satellites that multiple satellites that are overhead, and so they do have, as we said earlier, issues with cloud cover and at night. And here is at the bottom is a link to the Cropscape, which is where you could get this cropland data layer. And I'm pretty sure it's also free. They have information about crops at 100 different types of crops, as well as some non-agricultural elements or variables or characteristics. And so what they do is they kind of put these data sets together, do some analysis, and produce products like this. So we have a map, and the red areas are from floods. And so we could see, I can't even see from there, but if you kind of look closely, you'll see areas of red from flooding. But then they also have the percentage of the amount of area and percentage that's inundated or flooded. They do have a website for this information. So they have maps, but again, what's exciting to me is they have the geospatial data. So there's the data for you. Also, I'm going to talk later a little bit, or at least mention the idea of transparency and metadata, how important that is when we are trying to integrate data sets together like this. And you can get that information here at their website. So we can know about the methodology that they use and more. So keeping along with hurricanes, I guess it's a recurring theme. Okay. This example is a little closer to home. This is from the Bureau of Labor Statistics. We have something called the Quarterly Census of Employment and Wages. This serves as our establishment population, and it gives information about the employment count, wages for different industries and occupations. But it covers more than 95% of the jobs in the U.S. And this information is available over different geographic areas. So for states and counties, I believe, too. And the nice thing is it's easy to download the data. Okay, my common theme here. So here's the website for you to actually download the data. And you can construct maps. So it's kind of a way to, like these other tools on the map and the CDC tracking, it's a way to kind of visually and interactively select the data that you're interested in and then download it. So here is a screenshot of the website. Up here at the top, you have drop-down menus where you could select the year and the quarter. And I meant to check to see how far back this goes, but it does go back years. So you could extract data from the past too. And then you have different industries, I think whether it's private, the issue of ownership. And once you do your selection, you just scroll down to the bottom of the page and there's a little link. That's what I'm telling you because it's kind of hard to find, but you scroll down to the bottom of the page and it says you could download a CSV file. So in the past years, maybe ever since, I guess, Katrina, the QCW folks have created these hurricane zone maps. So it's kind of similar to, I think, what NAS was doing with agriculture, or looking at how cropland's affected by the flooding. Here we're looking at how are the employees and the employers, the businesses, how are they affected by in a hurricane. So these hurricane zone maps show total employment, wages, and establishment counts for every county in the hurricane flood zones. And they do this by linking information from the QCEW with data from the Corps of Engineers and other state emergency management agencies. So here is a screenshot of the hurricane page, hurricane zone map page. And here is, I think this was from Dorian. And so this is what is produced. So we have let's see, the establishments, I think that's the first column, and wages and employment, and then for different zones, and those are dependent, those are related to the level of the hurricane. So I want to just switch gears a little bit and start. So these were some applications of, I guess I'll say geospatial data science when we have integrated data products. But I want to talk about ethics. And somebody mentioned ethics yesterday, and I was really happy to hear that. And I've become more aware of this, I guess, in the past year, because it seems like I keep kind of running into it. But it's been a bit of an eye-opener to me. And I really liked what was said yesterday. It was you, right? Yeah, yesterday, because that was another aspect of ethics that I didn't think about. So I'm just going to just highlight some things. I'm hoping this will be some things that we'll talk about later in the discussion. So as we all know, hopefully, ethics is a study of right and wrong. It's not laws that we have to follow because that's what our government issues to us. But they're kind of abstract and they're guidelines, and they really depend on the culture too. So kind of the ethics that we follow maybe here in the United States would be different from some other country in the world. But there's something now called data ethics, and so it's a branch of ethics that's it kind of looks at problems related to data, not only just the data, but the algorithms, and then the corresponding practices and uses of the data. So there is a special issue of, I looked it up this morning, I don't remember the journal now, but it's something like, it's a philosophy journal, but the link is down at the bottom. And they had a special themed issue on data ethics. And this was kind of the intro article, and they talked about the 3 axes of data ethics. So one is on the ethics of the data, that's the collection, analysis of large data sets. And I tried to highlight in red here the things that I thought were maybe a little bit relevant to, or more relevant, not more relevant, but relevant to geospatial data. So the idea that we could de-anonymize our data, and I think that's a little more, I think it's more dangerous, or more of a problem, I guess I should say, when we have information on location, right? We heard yesterday about the Internet of Things. So another axis or aspect is the ethics of the algorithms. And I'm going to talk more about that too. So there's this increasing complexity of algorithms. We don't really have a good idea maybe of how they interact and what could happen from that. And then the third one is the ethics of practice. That's how are they being used? So there's the problem of privacy and surveillance, secondary uses of the data set. So, uses of the data that weren't intended from the beginning. And I think that's especially important when we're integrating data sets together, which I think also has an implication for ensuring privacy. And then unintended use. It was interesting because yesterday, one of the early speakers where he was talking about, we had seismic sensors, I think, and was using those which were used to detect earthquakes, but then he was using those to find locations of gunshots. Now that's a different use of data, but I think that was a good use of it, right? But certainly there could be bad uses of data. So just to give some motivating stories, there was a recent paper or article in the Washington Post about this racial bias in medical algorithms. I guess I should back up a little bit because when I was going to school, working on my PhD, I got in computational statistics. So a lot of the methods that I used were data driven, right? And so I used to think, wow, we should just always use data driven methods because the human won't be involved. The human's not in there tweaking something. The data is driving it all. But after kind of learning about these, the data can be inherently biased, right? And so then the bias that's in the data just drives the results in the models, right? And so this is kind of what happened in these cases. So it turns out that some companies were trying to develop models to predict people who would need more healthcare in the future so that they could potentially do some interventions and give them the resources so they wouldn't get so sick, so they wouldn't have to pay so much to treat them in the future. And they did not have race as a variable. But it turns out that the algorithms that ended up being developed were racially biased. And they underestimated the health needs of some of the sickest Black patients. And I think that could be in part because the data that's used probably had fewer Black people, patients in there because they didn't have the medical care, so maybe more affluent people would have, or non-Blacks. But so you might say, well, why is that relevant to a geospatial group? But it turns out that how this was in part discovered was somebody mapped out the most affluent scores. Where did the affluent scores land? And they were in affluent suburbs of Boston. So another more obvious example of this was this type of thing is in predictive policing software. So these models want to predict where are crimes likely to happen. So what's the input? Where crimes already have happened, which tend to be in certain hotspot areas. And so then they said, oh, well, we're going to add police to these areas. So that's where the police are. They see the crimes because they're not somewhere else, right? And so then there's more arrests. And so then it's just this feedback cycle going on. And autonomous vehicles. I think somebody mentioned that yesterday. How many of you heard of the moral machine? Just a few of you. Yeah, later you might want to try it out because it can take the quiz, I guess, or look at the case studies. But this was done by MIT, and they were trying to get at, how would people want autonomous vehicles to react in situations like we have here, where you're a passenger in the vehicle and you could either hit these pedestrians or you could swerve and hit the barrier, in which case you might be killed or your car would be damaged or something. And what I thought was really interesting about this is that they did the case study or the analysis collected the data internationally, so over 200 and some countries, I think, and it was in different languages. So you can understand, you can kind of get at this, how are ethics and how are these situations considered in different cultures. And one thing that was I thought was kind of amusing was they said that most people wanted a car to not hit the pedestrians but hit the barrier, but they did not want to buy a car that would do that. Okay, so yeah, so they wanted somebody else's car to do that, but not the one they were in. And and I keep thinking about this situation. I personally don't know what I would, as a driver, I would probably just swerve and hit the barrier, but it's a hard question. But so I'm almost at the end, and I just want to say a couple of things here. The working group that I mentioned last year, we had a geospatial interest group workshop. We have one every fall, and we focused on this idea of data quality with integrated data sets. But is there anything in particular, because it's geospatial data, that we need to consider? And I'll just point out that transparency and metadata seems to be the importance of that is like this recurrent theme, which I think that's important regardless of the type of data. But I also want to point out error models, because we talked about that a little bit yesterday. I think that's really key, or very important, I think, because especially when you're integrating models and data sets together, each one has its error. How do you make sure that we're kind of considering how the error propagates through the whole process. Everybody knows about this here, I'm sure, in this room, so I won't say anything more. I think these are important issues, whether we're modeling and integrating or not, but I think it becomes even more critical when we are doing those tasks. But I want to focus a little bit more on this in my remaining minute or two. In the article about the medical application, the bias in the medical application or modeling, one of the not the author, but somebody, a spokesperson, said, well, it's really easy to remove the bias. And I thought, well, maybe, but what happens if you remove the bias for that particular data set, that particular model? Does that mean then that you're just kind of adding some different kind of bias in there? And what happens if you have a different situation or different data set, and you're doing some of this prediction? Do you still have, the bias in there? So that just is always a little bit scary to me when somebody says, well, I'm just going to remove the bias. Somebody mentioned this yesterday, the idea of, especially with deep learning, artificial neural networks, and somewhere they're very brittle. They could be brittle, and then so they're not very robust. So we need to do more sensitivity analysis. And I think this is important and key when we are integrating data sets together. And what about data stewardship, the validation, the cleaning, especially when this is important when we're integrating data. This idea of privacy and surveillance, I have to ask Jeremy, since he's from the UK, but I watch a lot of British crime shows. and so they're always like, okay, CCTV. And so I'm thinking, wow, people are just like always under surveillance in the UK. I mean, is that true? Okay. Yeah, I mean, imagine it's in the States getting to be that way too. So it's a little bit scary because, and especially if you have drones up there flying around and you don't know they're there and you're under surveillance, and so there goes, your privacy. And we just talked about the Internet of Things. So I think that's pretty much it. I just have I'll just point this reference out here, that we did have a series of workshops for the data quality working group. You can get to the slides here at this link, and we also have videos of them. And so you could go back and listen to them if you want. And now for the panel. So I'm done. Okay. Am I still on the hot seat,
Okay.
though?
Okay. So I think we'll take
wanna go
some questions for Wendy at this point, and then we'll have a break and set up the panel after that. So my one question is how to turn this on. I think that's, yeah. That's...
So this is, I'm with Maxar Technologies. We collect a lot of data. One of the questions for you is, in the past, we would store all the data. The government policy for us. How do you see going forward when you have all the assets coming along? How long should we keep them?
I don't know. That's a really good question. That was something I think was discussed a little bit yesterday, or at least at the table I was at, because I think having the historical data is really, really important. And I don't have the answer. I would love to keep it forever, but maybe that's something that we need to invest in. And one thing that occurred to me yesterday when somebody was talking about data. So some of the data sets, are they really stored just in one place? Because I don't know who was talking about that, where he said, well, we had some on the Azure cloud and some. Anybody want to say anything about that? Because I worry a little bit about data. Oh, Ed? Okay, good. Because I worry about data stored in one spot, because what happens if.
I think in the early days when you were storing your data in the cloud, you didn't really have much choice, but now you can choose regions actually quite specifically where you want your data to be hosted, and that's largely for regulatory purposes. So in Europe, for many states, for many types of data, it has to remain in Europe or in North America and so on.
I was going to add similarly, at least in Europe, some of those issues of how long can you keep data for are now covered by the GDPR and so on. Now that's to do with personally identifying information, where you're only meant to keep it for an appropriate length of time for the task under which it was gathered. You're not allowed to reuse data that's personally identifying without going back to subjects. Different when you've aggregated those. That's maybe a different question. Yeah, and what about, that might be a little bit different too, but if you have something that's on the web, and then, was that part of the GDPR that if you want something removed from the web, that it has to be removed? Or if it's about you, then you have at least a right to request it.
So I have a question about that, because I think that storage has gotten so cheap that we should be storing all the data, although I think it depends on the kinds of data. The sensor data is really expensive, and I know Arlington County, where we're doing a lot of work, is already destroying data because of the cost, which, is sad. They don't know what to do with it yet, and so they're just getting rid of it. But when the data are in the cloud, what do you do about curation? Do you still need to keep updating the formats for it, or does, by being in the cloud by default, put it in a format that allows it to last forever, so to speak? I mean, so we have data on floppy disk, right? I'm making a joke, but
no, but that's actually true.
Right.
I do.
Tapes and things like that. But what happens when it's in the cloud?
Yeah, that's a really good point about data curation and the data stewardship and the media and the medium, I guess I should say, because I do have. This will really date me. Anybody remember Bernoulli drives? And okay. It's good when people know what you're talking about. But yeah, and then you think, oh, this is real. This data, it's here, it's safe, and then you can no longer read it because you don't have the ability to do so anymore. So
I was also going to add that when we built data.gov, one of the things we intentionally did was not to duplicate data, because the problem is you run into data synchronicity issues. And so what becomes the actual the actual true data set? There's many instances in the government where people would later be able to correct a data set or add a season that they hadn't gathered before, or give more explanation about something, or they decided to change the format of the data in a later year, and so they needed to go back and normalize it for earlier years. So rather than trying to sort of rehost things, it's much better in some ways to either create that URI on the semantic web or some other indicator back to the data source. On the other hand, the reality of the situation is you can still create backups of your data, and that's a very good thing to do, whether they're still on another cloud-based service or with that same cloud-based service or on premise. But the other thing is you have to understand that sometimes there are political whims. So for example, when President Trump came into office, there was a lot of concern about climate data. And so there were a lot of hackathons, which I totally support, to be able to say, look, we want to gather the data we have and make a separate instance of it, like a point in time. But it was very clear it was a point in time instance.
Yeah, that's a good point. And I think, wasn't there recent stories in the news about EPA, and then they had to publish all the data that um, was used in the study or to produce the results, regardless of whether it was going to violate people's privacy. So I don't know how. I think that's new. So I don't know how far that's gone, but.
Hey, Wendy, just one question. The waste data, I'm not expecting that it's publicly available, is it?
Ed, I'm glad it was an Ed question.
Waze does have a program for releasing data sets to local government, to municipalities for research as a partnership program. Google it.
Yeah, is it true that Waze is part of Google? Okay.
Just a comment on the data question. If you leave ethics, privacy, governance, and everything aside, from a software architecture perspective, I would say there's a separation between the data format and the data storage. So the data format is usually associated with how it's going to get used and what's the best way of storing in order to meet the need. So for example, if you're collecting data, you are streaming data and you want to collect as fast as you can receive them, the format in which it'll get stored is like IoT kind of friendly format, spatial temporal, and so on. And then there's data that has to get, I'll just say, massaged or manipulated to allow for better querying. So for example, if you're querying the data, you want a fast answer to that question. It's not so much how quickly you're receiving it, how quickly can you give the answer. So that's another, sometimes both of these can be one and the same. And then the third aspect is archiving the data, which is if you want to go to the past and sort of like rewind and play, you're probably willing to accept some time delays for the privilege of storing a large and massive amount of data. So all of these three things are separate. And then for each of these needs, you find the best storage possible. Whether it's short-term, but expensive, but super fast versus long-term archived cold storage. So you sort of like go from hot to warm to cold. So those are the two things. And with the cloud and so many other technologies coming in, you have so many options to consider those, as opposed to there's a one-stop place where you have to put everything and you pay at the same cost.
So I'd argue though that transition, you might want those data in the short run, but over time they could be archived.
Yes.
There's still a curation decision.
Yes, you decide, and sometimes that decision is made by the cloud provider to be able to compact that data and to store it optimally for you, so that you can make the request and then it decompresses the whole thing for you later on.
I think something we found at Ordnance Survey recently, though, is how things that were archived data suddenly become data that people are more interested in again. That after kind of 10 years of some of our national mapping being kind of regularly produced in a digital form, it's been produced for longer than that, but the last 10 years it's been fairly standardized. That people are now more and more interested in those past snapshots to do kind of modeling to present, to prove the models into the future, as it were. So it's, those archives suddenly become present data again. I think it's interesting.
Yeah, I would think that maybe with some of the remote sensing, but also, I guess it was yesterday, somebody mentioned something, but it seemed like the data that was being collected would be thrown away. But my thought was, well, what about, see my crime shows? I was thinking, what about, well, if you wanted to, find the person who did the crime, but also what if you wanted to go back and get evidence to say it wasn't you, or so yeah, so I mean
I think we'll take 2 more questions there too.
I just wanted to add a little clarity on maybe the cloud storage aspect of it. So my primary hat is the geospatial lead on the specialist team, but my other hat is storage. And I've been supporting our open data team for like 8 years now, I think. And so, you know, Ed said it right. So it used to be very nebulous. It's like you stored in the cloud, who knows where it was. But AWS was never built that way. When you stored it in our cloud, you were very specific about where you put it, in what region you place your data, right? And then I just wanted to add that when you make those decisions, all these decisions, you know, we don't make, the customer makes very, very specifically. So you want to put it in Virginia, you can put it in Virginia, put it in Oregon, you want to. But we have a lot of customers, for example, that have very valuable data. They will, you know, make decisions about primary storage. So where's the authoritative original copy of the data? And it's a trivial exercise to go, well, this is very, very valuable. And there's multiple reasons why you might do this, but I'm gonna have a copy of this on the other side of the planet just in case. And the whole point of the cloud is, right, we radically have reduced the cost of that kind of storage. So we're seeing customers that used to throw stuff away that don't anymore. I mentioned yesterday, we have customers that have, you know, thousands of tapes, right, tens of thousands of tapes. Now they have moved that. Now they have access to historical data at a scale they've never had before. Plus, you can control placing it in multiple parts of the world with very simple directives, right, at much lower cost. So I just wanted to add that. Plus, and I'm glad some of the format stuff came up. But you know, again, there are formats that are you know, driven by cloud requirements, cloud, you know, use cases. That are not, you know, old school on-prem formats that are new cloudy formats that make basically in situ use of the data possible, right? And that's a very important factor. Happy to talk more about that later.
We'll move on to the last.
Oh, good, another Ed. Okay.
So I'm all about data quality, and certainly metadata is important to that. And when you're doing data integration, so you're merging data from multiple sources that have different data qualities, it seems to me it's fundamentally important that we make sure we've got appropriate metadata to describe the quality of the result as well. Okay, and somebody mentioned provenance the other day. So part of that metadata, it would seem, should include the history of all the processing that's happened to this data, you know, in detail, to include the version number of the algorithm, because sometimes those algorithms change, and that means your data is different.
That's a good point.
Now, I've had people argue to me that, well, you're going to end up with this huge metadata file. The metadata might be bigger than the data. Well, that's fine, because you guys just told me the storage is cheap. So let's do the metadata. And maybe, because no human will ever look at this, maybe this is an application for AI. Build an algorithm that's going to look at the metadata and alert the human on whatever is important about that metadata there, or that might have changed or need to be updated, and that sort of thing.
Yeah, that's important. I didn't think about metadata for the algorithm. And pedigree's huge too. Somebody mentioned pedigree yesterday. And one thing I had a thought yesterday was somebody mentioned about standards do that, and I'm paraphrasing, but it seemed like it was like, do standards stifle innovation? Did I get that right? But anyway, so I'm wondering if maybe having better metadata, could that sort of alleviate that, so we don't have to have like strict standards? So could we have more metadata rather than and then fewer standards? Who's the standard person here? Somebody was
Everyone.
No, somebody was like, I do the standards. But
Maybe we can come back to that one in the panel. It sounds like.
All right, that's my provocative question.
I'm sorry, we need to take a break now. We can pick up further questions in the panel. Wendy's agreed to sit on the panel with the other speakers. So thank you.
Didn't get rid of me yet, but
we'll take a 5 or 10 minute break now just to get reoriented for the panel and then come back. So. Yes, panelists, if you, especially those who haven't spoken to me already, come up and we'll get sorted out. Like we're suspending recording.
Hi. Good to see you. From DC.
Okay.
Yeah. Yeah.
You know, the traffic in the Bay Area.
Glad to have made it. And glad to be able to spend the whole day. So, yeah, I was bummed to miss yesterday.
I know there's, there's plenty of leeway in
East Bay.
Okay, yes.
So
and we'll
there's no
stick
good
to
way.
the
Although
orders
it's,
on the webpage.
if everyone else is presenting them, I can get my own.
Just the back way.
It's entirely up to you. I think.
I just don't want to be.
I could go back up to the city later.
Hi, Jeremy. Are you using slides?
No.
Fine. So
Okay.
two of you aren't.
We will not use slides.
Two are. That's
Not a
fine,
slide
yes.
person.
Yes. Okay, brilliant.
Hi,
So we'll
Megan.
stick to the. I'll put this back in. Actually. We'll stick to the order that's on the webpage.
Okay.
To go with that.
Which is, do we know?
Yes. That. Hold on.
Yeah.
I'm gonna go find the restroom quickly.
Yes. Okay. Might be easier off my phone.
Hey, Ed. Steve Ford, nice to meet you.
So it's Regan, Megan, yourself, and then Ed. Perfect.
That works.
If we're not too over, I might say a few words as well. But, all right. I'll go last and see if there's time. Do you want to plug in straight away?
Yeah,
I think
yeah, might as well.
You're first on, aren't you? So.
Seems like there's a few ads here. Are you part of this?
Yes. The last of the.
It's Regan, yes.
Fine, okay,
Yeah,
yes.
and Smite.
Okay. Ah, yes.
But I respond to any of the 4 iterations of my name that I
Yeah.
often get. But it is Regan.
Mine is usually pronounced right, but I have a problem with E's. People want to put E's in all sorts of
Oh,
places.
I'm married to a Jeremy. So
Yeah.
I have to tell you that.
Morley as well is one where they drift around the name as well.
Yeah. No, that's, yeah.
Let's try plugging in
Okay.
and make sure everything works. Let's plug the HDMI into
Oh,
this one.
into
Yes.
that.
Real knitting.
Email me. Actual thing I'm supposed to be showing. Is this it? All right.
Brilliant. That worked.
All right. See if I can sneak into the restroom.
Yeah.
I give up. It goes a long line.
I know, there's only two. And
Yeah. Yeah. They suggest you going across the White House. Like, I'll do that later.
Yeah.
Or just find a friendly, googly looking person. I found that to be effective.
Yeah. Show me to your restaurant.
Show me to your restaurants, yes.
We'll have so.
Yeah,
I'll drop in here. So after the so late presentation, so we'll just sit people down and my hope is that they would like there'll be enough questions or we I don't have many questions if it's quiet to get things going, but I'm hoping yesterday was 3 different sessions. What the one was the best.
Yeah, the talk.
And that'll lead into a discussion. Some people can stay here, but otherwise we go for a big discussion.
Is the right way to think of the word survey where you're like more like NGA or more like you know the name of the National Geospatial Survey that we have?
USGS.
Yeah.
We're closer to USGS, but we're not interested in environmental. We're interested in geological.
Like to include bathymetry as well.
No, that boundary we have the UK. That's the marine data on that data. So yes, we Yeah. But we're split up in different areas, and that we do that topographic mapping, the environmental literacy, the environmental mapping, and the geological service, the geological structures. Land registration is a different thing. The geospatial picture is kind of uniform topographic with the matter. The last couple of years, we've the government has set up a thing called the geospatial commission. As much as anything about licensing. So we do have like that. Sorry, technically,
primarily bring subject matter experts and leaders from outside the country for so we're all senior citizens, but for modern technology best practices, data best practices into government. And then from our seat in Office of Secretary, we work on technology acquisition reform because we require access barriers, not require software or any of those other things. Like, it makes no sense. So the Defense Digital Service here, we have been working with the UK to set up a different service there. And so they've actually just launched. It's actually an interesting circle because the UK digital service started the government digital service, yes, was the original like digital service. And then the US digital service started and copied the UK one. And then where I work was originally an agency digital service. So we spun off of that kind of DNA to focus on digital. And now we are consulting back with the UK to say, okay, you want to start a defense digital, our lessons learned back to you because the government digital service has taken a different approach. We spun off lots of different agency teams on this side, and then they've been more centralized. We're looking at setting up their next little bucket.
I think that GDS thing can be very useful in centralizing a plethora of websites. One hierarchy and stuff.
At one point, you like couldn't get a new website, and the government website, you can't go into it, which is sounds like a small thing.
Oh, I think that's probably HTML.
So that's what everybody will use. Yeah. So you can plug in. Perfect. Good.
I think it's hidden in the richness that was on some of the agency websites, but it makes it much more valuable. You've got that experience. I'm feeling people back together. I don't know if you want to here and then or as everyone presents, they can come up and present and maybe
Where do you want to do?
Let's do that second one. I think that's quite nice. People come up. No, go up from the audience.
Oh,
make your presentation. Okay, everyone, if we could start reconvening, we'll start again in a minute or two. Okay, I think we're set. It's always good when you see the first speaker walk back into the room. So on to the next panel session. We have an interesting set of speakers for you across a range of application areas. So like yesterday, but to explain if you weren't here yesterday, we'll start with brief presentations of about 5 minutes or so from each of the panelists, and then we'll go into questions. My hope is that there will be questions from the floor. I have some backup kind of things to prompt people on if need be, but I think it'll be mostly over to you guys. Something I didn't mention at the start that I should mention again, especially as we're coming into questions and so on, is that this is a recorded session, and the recordings will be available online afterwards. So I suppose in some sense treat this as a public forum from that point of view. So otherwise we'll go into the first presentation, and I'd like to welcome Regan Smith to the podium. Thank you.
Hi, as Jeremy said, I'm Regan Smith. I'm the Director of Spatial Analysis at NatureServe, which is a biodiversity informatics network. We manage information on imperiled biodiversity across the Americas, serving as kind of the hub of a network that has scientists out in the field collecting information to answer key questions about species and ecosystems. Some of those are up there on the side there, but that's things like what is it? So standards for taxonomy and classification. Where is it? Which is what I'm going to focus on today, given that location. And then how things are doing. So we assess the health of, we help figure out what's imperiled, what's doing fine, and then that information is provided out to other users so they can make decisions about conservation and land management. So while we are a conservation nonprofit, we're really in the business of data, but data relevant to species. So what I'm hoping to do with my 5 minutes today is tell you a bit about one of the projects we're working on that kind of brings us all together, specifically in the realm of data science and how we can pull new information out to answer that where is it question. And given that this is the outcome session, I'm going to be focused on how we can answer this key question related to species extinction. Some of you may have seen the headlines recently, estimates about 1 million species going extinct worldwide. We're kind of in this moment of biodiversity crisis, and we're trying to figure out with the data we have at hand and kind of the new spatial analysis methods, the new proliferation of ways to measure the environment and make sense of that with kind of big computing solutions. Can we address the extinction crisis, and particularly with the project I'm going to talk about, can we do something about this mismatch between where you have areas that are important for biodiversity and areas that are protected? So for 40 years, we've been collecting data like this. Those are some of the species we track. The numbers on the side are ranks of how well they're doing. So something that's a G1 is globally imperiled. There's not very many left. They're in trouble. The scientists in our network have been out there in their field boots, with their instruments for 40 years, collecting those dots on the map. So those are delineations, documented occurrences of where these things occur. Now, the problem is, people can't be everywhere. There's not millions of dollars for field biology inventories. And so this map it provides really valuable information, but it's totally inadequate to address that species extinction question. We only know what's going on where people have been. We don't know anything about those blank spaces on the map. And there's a lot more blank spaces than filled in spaces. Because of that, people like the Fish and Wildlife Service, who are charged with managing these species, often take a pretty conservative approach, and they create big range maps like this to say, well, the species occurs in this region, worry about it there. So if you want to build a highway, in the Northeast, if you have an endangered mussel, that's going to be your concern. You're going to have to spend money assessing it. Conversely, on the other side, if you want to protect a mussel, do it somewhere in there and maybe that'll work. And that, again, it's not going to address this critical question we have. So that's where the data science piece comes in. What we've been doing at NatureServe in partnership with technology supporters is building predictive models to more precisely map habitat for all these species. So taking just one species from that previous slide, on the far side there, you see those polygons where people have been out in the field and said, this frosted flatwood salamander, which is listed as threatened under the Endangered Species Act, has been observed at these locations. And what we can do with that is combine it with this wealth of geospatial information characterizing climate and soils and land cover, run predictive models, use machine learning approaches like random forests to bring that data together and then project out where you have similar conditions on the ground and produce a refined habitat map. What this looks like in practice is something like that. Here's our map for the salamander. On the side there, you see our prediction of habitat suitability. So the yellow areas are where conditions are suitable for the species. And then on the other side, we've just thresholded that. Multiple thresholds. So what you can see is if we've gone from a map like that on the left, where we've seen it here, it might be here, to this much more precise delineation. And that's kind of the power of what we're able to do now for individual species. But the exciting thing is, with the data science today, we can start doing this at scale and for many species. So this map is just stacking up models that we've built for all the critically imperiled species, amphibians in the United States. And the areas that are pink and yellow are where you have concentrations, places where we really can focus conservation resources. In the past year, we've done this for 2,000 species, and we've done this by pulling together the data collected by hundreds of people in the field, building a kind of cloud-based environment where we could have a team of scientists collaborating on the modeling, and then using tools to get that information back out to our scientists so they could review it and tell us how well the models have done. Taking that one step further, we've done some further analyses, looked at where not only you have many species occurring together, but also where those species aren't protected or where there's only a few opportunities left to protect them. This map is showing the outcome of that. The green areas are areas that have been protected, and the yellow areas are where you have concentrations of biodiversity that need protection the most. So these are our conservation opportunities if we're going to address that extinction crisis. Just want to point out, you are here. If you go on a really long walk, you could get into some pretty cool places. This is one of the places in the country where there really are concentrations of cool stuff. But what's been kind of keys to the success of this, we're producing information that people have never had before. We're producing it at scales that are actually actionable for the first time. But for this to work, there's several things that are necessary that I think are probably commonalities across the various work that a lot of us do. So for us, because salamanders don't use Waze and there's not, this proliferation of data from the natural world that there is in some other realms, having standardized ground truth data about the environment and what's going on the ground. So those 40 years of field collections from our network are really the basis of what makes this possible. And having that information come in ways that are standardized. People mentioned yesterday the 70% of the project time that goes into dealing with the data. When communities get together ahead of time and set some data standards, it allows us to do work like this, at scale in ways we couldn't otherwise. The other thing that's made this work possible is really that partnership between, big tech and tiny nonprofits like NatureServe. As the woman from the California Utilities Group said yesterday, there's so much that's possible now and so many pressing problems that can be addressed. But often the people who are at the leading edge of the analysis to do so aren't connected to the people on the ground who either have the data or who know the questions to ask. So having that partnership with Esri and with Microsoft has allowed us to do this, not just for 1 or 2 species like we had been doing in the past, but really massively, at a half continental scale. And then the last point I wanted to make of kind of key lessons learned is with this kind of modeling, and this has come up before too, the trust and transparency is a really big issue if your results are going to get used. What we found with this is, while it all sounds great to us data scientists, is there's a lot of distrust about, what can these models actually tell us? Is this information good? You don't know what's going on with this plan I've studied for 30 years. And so finding ways to make the process open and to pull the people with expertise in a review capacity. I mean, we created models for 2,000 species, and then we put them all out in front of people. And they, learned that, good, real, useful information could come out of that. But on the other side, the data scientists, we learned that, these are the situations this works for. And in a lot of situations, it doesn't work. Or, the field people can go out and get additional data and feed it back in. So that's really one of the biggest takeaways for me, is just that for us to have maximum impact in our work, we need to be open, and we need to be listening to the community of end users and able to communicate how what we are doing can, and what the limits of it are in answering whatever question we're trying to address.
I'll switch to camera, and Megan's next. So Megan Furman from the Defense Digital Service, who hasn't got slides, so we'll leave with the camera view.
Okay. Hi. I'm very short. Hi, my name is Megan Furman. I'm the Deputy Director for the Defense Digital Service in the Office of the Secretary of Defense. And what that means is I'm part of, oh, that's like magical. That's technology in action.
I saw this
right
earlier.
here.
I was waiting for the right moment to use it. I think
This is amazing. Oh, that's perfect. Yeah, that's great. Actually, Mike's a little short now. I'm not quite that short.
It's all right. It's all right.
Oh my gosh. Yeah, you're really tall. Lucky person. Am I in the camera? Oh, I could go this way.
Can you scroll that camera?
Oh.
Yeah, I should have known where it was at. Control camera. Boy, you guys go with the obvious labels, don't you?
Yeah. That's actually a wonderful segue, because what the Defense Digital Service, or DDS, does is we are a SWAT team of nerds inside the Office of the Secretary of Defense. And the concept here, what was that?
SWAT team of nerds.
SWAT team of nerds. We are primarily folks who came from industry to do 2-year terms with the federal government. And so what that means is we have a bunch of folks from Google. I spent 6 years at Palantir Technologies. We have folks from Akamai, really excellent technologists coming to the government and saying, here's what good looks like, and helping people make better decisions. Because at the end of the day, the people who show up get to make those decisions, and trying to bring a technical voice and technical expertise, whether it is data science or engineering or user research, really, really matters. So what DDS focuses on is a combination of technology acquisition reform, because the way we acquire battleships and into aircraft carriers is not actually a good way to acquire software tools or data sets. And so what you can end up with are 2 or 3 year requirements generation processes where at the end you've actually defined away part of your solution set. And part of what we do is try to change that and make it better. We also take on our own projects where that means we bring those modern technology practices into the government. Sometimes we are taking projects that are floundering a little bit. Other times we take projects that are new. So when the government thinks about transitioning to the cloud and cloud migration, how do you go about doing that when what you've always known is a data center and your procurement officer has always, bought bare metal servers, and then you go and you install those things? That's actually a big transition to ask someone to make. And so we do sometimes a pathfinder, an illustration. We're working with the Marine Corps right now to say, you have a particularly challenging logistics system. Let's do some user research. Let's look at what changing your UI and your data management system would look like on the back end. And in the process of doing that, we're going to migrate you to the cloud, and we're going to show you how to do it. This is going to be a well-documented approach. We're going to help get through all of the policy and security hurdles, which often exist for a reason, but sometimes don't. Sometimes the biggest thing you can do is just ask the question, why is this like this? Can you show me the rule that says I can't actually do this thing? And often people can't. And so one of the values that our team brings is, while we don't know all of how to work in the government, we bring kind of a fresh perspective where we can ask those questions and then say, well, here's how Google does it, or here's how Akamai has done it, or here is how name another company has gone about doing these things. And in the process of that, bringing modern tools, modern technical stacks, and starting to be kind of a pathfinder and illustration there. So we have been part of, from thinking about an outcomes perspective. The Jedi Cloud acquisition started from this office. We have done a variety of capacity building programs. So when you think about starting to hire a data scientist, how do you go about doing that? How do you make sure that it's not just someone who put data scientist on their resume, but doesn't actually have the training? How do we set up those processes and empower folks to do those things better? So it's an office of, I say it's a SWAT team because we also work on, we'll be called out to do work on things like the PCS process. So when a military service member is moving, usually every 2 to 4 years, they and their family pack up their whole house and they move. But that is not done by the service member. That is actually coordinated almost entirely by the US military. And in 2017, coming into the summer PCS season, the website that folks used to manage their moves only had an uptime of about 20%, which is crazy and unreasonable. And so we had started hearing about this, and finally someone walked in our door and said, hey, my family is supposed to be in Hawaii in 2 weeks, and I am starting a new job, and I can't schedule my move because this website is down. I'm not really sure. And so that gave us the space to work with US Transcom, which was responsible to do an initial fact-finding mission to go and get those servers back online for the near term. And then in the long term, work, what would it look like to actually have a system that works for a service member and their family when they need to move, to give them the information they need on the time that they need it, to allow people to log in and do things that are very, very simple and basic. And then if you're storing the data correctly, project out, what should this look like in the future? How can we pre-stage things? How can we know when the actual bubbles of time are when people tend to move? Everyone thinks it's the summer, but there's also a couple other times in the year. Maybe we can plan ahead for that. So those are a couple examples of the types of things that we work on. Data is absolutely foundational to all of these things. There is a huge push to use AI and machine learning in the government right now, but if your data is not ordered, if it's not available, if it's strictly across silos that you can't access, it's really hard to do effective machine learning. We're also discovering that when people say AI and ML, often they just mean a linear regression, some like very simple statistical methods, and you're kind of like, well, I could do that for you. You don't actually need machine learning for that. Just do a linear regression. Let's see if we can find some statistical significance in here. Don't make it more complicated than it is. Sometimes it's a very simple solution. It's asking, why can I or can I not do this? What does the data actually say? And then helping people get access to the right data. So that's the kind of work we do. I'm excited to talk about it. I should also say, from a capacity building perspective, oftentimes we've seen people don't always know what they're asking for. So we were talking about security and privacy earlier. You combine two data sets and you get an unexpected outcome. One of the things that we try to inculcate into everyone we work with is thinking carefully before you do those things and saying, what is the security implication of this? What is the personal and security implication of this? So that we are actually bringing those correct ethical moral practices along the way, which is something Wendy talked about, so I wanted to mention it. Thank you.
So I'm not sure if we'll have to raise the desk again. This is truly exciting. Yeah. you can adjust it how you actually like it. So Stephen Ward from Climate Corporation, also without slides, so we'll stick with the camera review as well.
Yep. Apologies for no slides, but I have a tendency to read them, so I just felt like it was going to be best to talk to you guys. Climate Corporation, who are we? We are a subsidiary of Bayer. Think of us as the digital arm of Bayer that is sort of at the forefront of this agricultural revolution that's occurring right now. Many of you may be aware, but the ag industry over the past 100 years has gone through a couple of pretty extreme inflection points. One of those being mechanization, another being the implementation of new chemistries and new modalities and modes of action in chemistries. The third in the 90s, very hot topic right now being biotech and biotech traits and pairing those with chemistries. It's our belief at the Climate Corporation and within Bayer that the next inflection point, the next real shift in the agricultural industry is going to be data-driven. Data is the new currency in agriculture, without a doubt. Farmers, seed salesmen, chemistry retailers, they are swimming in information. To give you an example, we offer a handful of products on the market. We have over 1 million downloads of our products. We collect over 5 million hours of machine data every month. We processed over 500 million images last year from drone satellites. We have over 180 trillion data points across 100 million acres of the globe. And guess what? There are no standards in the ag industry. Everyone's doing it differently. We are dealing with a hot mess. And it's taking every bit of brain power and technology that we can combine to make sense of this all. And that's really what we're trying to do. We want to offer the ability to the growers for them to see their activities and their operations through a different lens, through a lens of data that's always been there, but it's been buried. It's our belief that every pixel of information, every square meter on the farm holds a story. Right now, only about 3 or 4 chapters of that story have been written or interpreted. It's our job, we feel, to help interpret the rest of that information and the rest of that story and bring it to a sustainable end. Our goal is to allow farmers through data to more sustainably improve and increase their practices. We've probably all heard that by 2050, we're going to have so many more billion people. I've heard every different number in the world. We can argue about those numbers if you want. I think we can all agree that there are going to be a lot more people in 2050 than there are now. We're going to have to feed those people. What that means in terms of the amount of production or the amount of reduction of waste is up for debate. But the reality is we're going to have to do one or the other, probably a combination of the two to make things work. So I've been very fortunate in my career. Despite, don't believe this baby face, I've been doing this for 21 years. Okay, in the geospatial tech industry. I've had the pleasure of working with some of the folks that are sitting in this room, and I've learned a lot along the way. Started my career in habitat suitability analysis. Love seeing what you were talking about. Love seeing that you weren't showing county and parish maps. I'm from Louisiana. We have parishes down there. And that you've graduated to actual, really concrete, delineated boundaries. Moved from that into the intelligence community. Spent quite a bit of time running fusion and pattern analysis teams and predictive analytics teams at Special Operations Command and Joint Special Operations Command, working for DIA, CIA, and some of those other three-letter agencies. Grew really frustrated still having to work with Internet Explorer 6 in classified space. So I got lured out of that concrete box in Tampa by the Climate Corporation to get back to my roots, where I came from an education standpoint. And I was really looking at spatial statistics in the environment, particularly with agronomy and soils, and have been running a data insights team for climate now for 5 years. That team has grown from 9 remote sensing scientists now to over 60 weather scientists, remote sensing scientists, geospatial statisticians, AI, data scientists. Throw in every IST that you can think of, and we've got a good mix of it. But the beauty is, and what I really enjoy right now is, and the approach that we take in this world of no data standards, our mission is no different. I'm able to combine that traditional intelligence mission that I worked so hard on for so many years in the government and bring it into industry to solve growers' problems. We're taking the traditional approach. Everyone can tell you kind of what's happening. Some people can tell you where it's happening. We're really striving to tell you why it's happening. And so getting down to farming by the inch is where we're trying to move. Now, that means that we have to work with multiple sets of data, multiple pieces of information, qualitative, quantitative, different resolutions. It was mentioned earlier in the talk this morning. There are no good ways. There are a lack of standards for combining data that suffer from MAU issues, that suffer from spatial non-stationarity issues, that suffer from all of these problems that we face every day. And so we're lucky that we're not only doing the research to help farmers right now, but we're also focusing a significant amount of our efforts in establishing these standards. We're very active in the STAC community. We're very active in the open source community. We're rewriting PySal for distributed systems right now. And I think it's incumbent upon all of us in the room to contribute back to the community that we're all working in. All of these are going to help drive data standards, and we'll get into it during the discussion, I think, on the panel. I have mixed emotions about data standards. Someone mentioned the constraints on innovation and that they potentially cause. I am a proponent of that. I do believe that they constrain innovation, but at the same time, they're a necessary evil. So with that said, I'm going to wrap up. Happy to talk to anyone else about climate and what we do. I'm excited to be here, and thanks for having me, Jeremy.
Are you connected?
All right, well, Jeremy gets me connected. I'll tell you about myself. So I'm Ed Stracco. I'm with the Bureau of Transportation Statistics in the United States Department of Transportation. I run the Office of Spatial Analysis and Visualization. So in BTS, we're all about telling the story of transportation through data, statistics, maps. My group, we do a bunch of cartographic products. We put the National Geographic Atlas database together, about 80 different layers. And we also do a bunch of different spatial analysis. We're one of the 13 principal statistical agencies in the federal government, and we're all about being objective and policy neutral. And the currency we trade in is trust. We ask you very sensitive questions if you're a business or you're a person, a household, and we have a lot of protections that we put on that. We have civil and criminal penalties. We have a pledge of confidentiality. We will not share it with the Department of Justice, with the Department of Homeland Security, with IRS. We take the really good care of the data, and we really, that if we don't have the trust, we can't get the data that we need. And on the other side, in this era of fake news, we have to make sure that you trust the data that we're putting out there, that this is authoritative, this is real, you can believe in this. The stuff Wendy puts out the unemployment statistics, and you think about that, I mean, that moves markets. So we need to make sure that we have your trust that this is real. So as we enter the space of data science and geospatial, we're very timid. And we want to make sure that we get this right. And I mean, we've been thinking about statistics and statistical methods for 100 years. So we've refined how we sample things and how we deal with error. And I think Lauren yesterday was talking about bringing science into data science. So how do we learn this new science, and how do we do it safely? And when can we accept bias? And really, it's about fitness of use when we get in and start using data science in this space. I think yesterday, Kathleen and Todd did a great examples of how we're using data science in transportation. Wendy this morning showed another example. So I'm not going to go into a whole bunch of examples. I'm going to throw out a couple slides, some of the bigger picture things that we're thinking about. I think it's ripe for us to be thinking about right now as we look at geospatial and the integration of data science. So when you think about the transportation system, you can cut it a couple different ways. You got freight and passenger, you got public and private, you got real time, like I'm going 75 on the 101 in a vehicle and I could die. Or I got real time, like imagining a system, or I got archived and doing a model. So we can kind of think about those. We also have the system level and then the project level. And some of what's driving us in this area is the scalability. We've focused a lot on GPS in the freight area. So we like that a lot. We're starting to get into the imagery, but it's kind of tough to scale at the temporal pace or the quality at a national level. It's good for cities, a little tougher. I mean, video cameras, we don't control video cameras for the whole country. When we're decentralized, if we were Singapore, that'd probably be awesome. But you know, we're not. So you know, it's easier. FAA is part of us. We get all their GPS data. Coast Guard, we're able to get all the AIS data from all the ships. We have a partnership with the trucking associations. We're able to get 1 million trucks, 60 billion points in their GPS every year. So that's where we've been working. In general, the freight system, that's what I think we should continue to look at. Back in the 70s and 80s, they were deregulated. Totally changed the industry. Very low barrier to entry for trucking. You just have to have a license and a truck. And so people were competing on technology. And you saw these firms as leaders and how they're going to separate themselves. And so when you think about package and parcel delivery, you can track your package anywhere. They've been forced to really invest in location and data science. How am I going to do optimization of 1 million packages? I got to get them there by 9 a.m. I see that every day. And whether it's the trucks on the road or the planes, you got to get all these planes into Memphis, into Louisville at nighttime, unloaded, back out, and to another airport in the country at 7 a.m. It's a lot of optimization there. It's not just that. We see it in the shipping lines. The ships we see, the container ships, gone to 18,000 TEUs. That's a 20-foot equivalent unit. That's one of those short containers. Big ones are 40 foot. That's a lot. How you pack them on a ship in Asia, how you get them over here, how you offload them, how you deal with them in a yard, how you stack them, how you move it around. We're seeing a whole lot of that. And then, of course, just management of a fleet, whether it's a truck, you know, if something's wrong, phone it in, you know, ahead. Hey, I need a part, get it on so we can get the truck back on the road. Or railroads. Railroads are very capital intensive. Having precision railroading, all those tracks, where do I need to be spending my limited resources to actually make those corrections so I can run trains at speed, I don't have slow orders, or that I'm not derailing a train and blowing up a city with a train full of oil. So as we talked about edge computing yesterday, I see that's where we're going to see it first. The next thing I wanted to touch on is shared mobility and connected and automated vehicles. Shared mobility wouldn't exist if we didn't have this conversation, right? We wouldn't know where our dockless bikes or e-scooters were. We wouldn't have ride sharing, ride hailing. An area I'm very interested in is the data sharing. We talked about data trust yesterday, and how do we bring that data together? Everybody's asking for this data. Although, I mean, when you think about the transportation system, it's teeny, but it's very hot, very sexy right now. How do you bring that together, anonymize it so we can look at it together? And also some of the standards we're seeing come out of there. A group called Shared Streets. It was created by the World Bank and the National Association of City Transportation Officials, kind of looking at a global standard for linear referencing. How can we do this so we understand what's going on in the street? How can we go between different geospatial layers? Connected and autonomous vehicles, two things. They're not the same, they're related. Edge computing works well for autonomous vehicles, but you need something more. You need that mesh for connected vehicles. And it's also, you start to think about who's in control, and really want to have us think about HD maps. And you think of the layers of HD maps. You got your base layer of where the roads are. You got your geometrics. Then you got some additional layers up there, and it's a semantic layer of what are the signs, what are the signals. Well, we got to create that. How would we create that standard? And there are 91,000 units of government in the United States, and a lot of them own roads. So everybody has to get in with these standards. And the person at a little municipality who is the Department of Public Works Director, is the Chief Data Officer, also drives a snowplow. So how are we going to do this that everybody can actually accommodate this? Not just 50 states. Then who owns the maps? Is it the OEM? Is it the map provider? Is it the federal government? I don't own anything. I own 1 mile of road out in Virginia where we test cars. So is it the states? Again, lots of people. Where's that liability? We need to be thinking about that now. As we are looking at the semantic layer, one of the efforts we're doing is work zone specification. We're putting out some grants, so anybody's interested in money or trying this out, come and look at our website now. We want to figure out how to get this work zone standard out there and adopted widely. I mean, autonomous vehicles and connected vehicles, they don't like uncertainty, and work zones are very uncertain. You could have a utility truck parked for 10 minutes, fixing a line. You could have something closed for six hours, 6 days, 6 months. How do you deal with that in there? Transportation and planning and engineering. This is kind of inside. Infrastructure owners and operators. Two things here. The convergence of GIS and SIM and BIM, the civil integrated management and the building information modeling. Kind of think about smart cities. For transportation, how do these two come together? Different purposes, different scales, different precisions. As we're looking forward, it's kind of the Wild West in BIM and SIM right now. What do we need to be thinking about in standards, and how to relate it to the GIS world? I also threw up a transit map. This was a really good example of why standards and specifications work. Back in the 90s, one of the things, what's the extent of the system? Well, where are all the transit stops? And Ed's mentioned, hopefully we won't have transit stops in the future because we have inefficiencies, but for now we do. So we hired a university, did the whole country, every bus stop in the world, or at least country. Took a lot of time, a lot of money, and it was wrong before it came off the plotter. So we couldn't do it again, so we just maintained the transit stops. So then GTFS came along, great opportunity. It allowed us to very seamlessly, easily pull them all together to create a national map and actually start doing data science on something. We couldn't have done it without that standard that everybody had adopted and was using. The question I have is, why was that so successful? How can we make that successful in other areas of transportation or other areas of geospatial and data science? That everybody was adopted, everybody uses it, and it's not some standard that sits on a shelf. I want to wrap up with transportation safety. This is really, at the end of the day, this is it. We're still killing over 36,000 people on highways every year. We got better. We killed 1,000 less last year, but still way too high. You think of Boeing, 2 planes crashed to ground the whole fleet, right? We're still killing a lot of people. I put these 5 examples up. We did a data visualization challenge. We had some different players in here and using data differently. University of Central Florida using ITS data. All that data we've invested in over 20 years, they've used machine learning to do short-term predictive analytics on where are crashes going to occur, where do we think we need to be focusing our attention, changing the variable speed limit signs, giving the infrastructure operators some information. Ford and Arity, they're looking at the behavioral information coming off the car, hard starts, fast starts, hard stops, people using cell phones, and using some data science in there to get down that number of fatalities until we can really achieve that that vision of a much safer road with autonomous and connected vehicles. So with that, thank you, and let's have some conversations.
I think Wendy has agreed to join the panel as well to pick up on that as well. So I'm hoping there'll be plenty of discussion from the floor here as well. So do we have any first questions, please?
We can check. We're friendly. Yeah.
Okay, hi. Hello? So yeah, my perspective is as an investor. Oh, I'm sorry, Todd Simon with Geospatial Alpha, and also a venture partner with London VC called DN Capital. So that's my perspective is investing and also nurturing startups that derive or create geospatial intelligence from geospatial data. A lot of it's satellite oriented. So I actually have 4 different questions for 4 different people that aren't connected at all. So you can decide. We'll go with the first. Yeah, and then you can. Well, I'll toss them all up very quickly, and then you can maybe decide if they should be done offline, perhaps. I guess. So Stephen, I think I wanted to. We're considering an investment in hyperspectral satellite, and I'm thinking about a lot of different things. One is there a really strong correlation between the narrow bands and signatures for biology. That's part A. Part B is the cost prohibitive, and you would know if that is the case. So that's my question. Should I invest? I guess. And, well, we're just gonna. Then you can just dismiss some of these. Megan, we do some work with the DIU, and I'm curious if you're more focused on sort of enabling and onboarding existing technologies or exploring and discovering new ones, which is what DIU does a lot of. And then, Regan, we got a partnership with a group out of Stanford that's developing PandaSat, which is a dual technology, 1, microchips for small species, and 2, micro satellites called chipsats to track them. And it's starting with pandas. And I'm curious if you actually contribute capital to projects like that can then be ingested into your data system.
Take the hyperspectral one offline and seeing how the time goes. That seems a bit more specific, but should we just run down in order?
Sure. So, so DIU is a Defense Innovation Unit. For folks aren't familiar, they are focused on, like you said, a lot of investment in finding small companies that are not traditional, traditional systems integrators, large-scale contractors, and bringing them in to start working with government. The way I think of like DIU versus DDS versus like the Office of the CIO and DARPA and IARPA and then things like that is DIU is really focused on how do you nurture the companies and the technology from outside government to bring that in, which is incredibly important. There is so much specific information about how do you do government contracting that just is a learned skill that needs to be spread more broadly so that more people can compete and we can get better technology coming into government, not just for defense, but across the board. Otherwise, you leave giant holes of things that you should just be able to get your hands on and work with. DDS is more focused on the people side. We'll take projects. We do work with DIU but less on that investment side. They're really more focused on investment. The CIO shop for the Department of Defense, very policy oriented, and then DARPA, very long-term projects. So I think there's space for all of these different types of innovation organizations. I think, you know, we need to all make sure that we coordinate together and we play together well, and we know where projects and people are moving across the ecosystem. And that is sort of the way I think about that whole space, which is incredibly important and varied.
Wendy and Ed, do you want to comment from different places in government here in the US about bringing in innovation and so on?
Well, I guess I want to echo what you said, that it's hard to navigate, well, both sides. It's hard to navigate the whole contracting, process. And I used to work for the Department of Defense, so I know how important it. Yeah. Well, I know how important it is, and they do strive to, bring in new entities and to work with small businesses. So I think that's really important for innovation. So.
We like to do both. We like to take calculated risk, and we think it's okay to fail. It's okay to fail for maybe $100,000, not $100 million. But we want to take the risk that the market won't subsidize that to get that new technology in there. But then when we go into more production and we scale up, we are looking at how do we adapt the existing technologies and frankly, existing data. So I love trash. And so I collect very little data. I use other people's trash for almost everything. And so you have to make sure you use it correctly. But definitely reuse of other data is key for us.
And there's one other question for Regan about specific tracking.
Yeah, so we are not heavily involved in kind of the microsensor world, and though there's a lot of interest there, I think the challenge often is, we're a relatively scrappy, not particularly resource-rich nonprofit, and we're also primarily function as the hub of this network. So within our network, we have programs within academia and within other, even state government, who are definitely utilizing and like dipping their toes into those areas. NatureServe itself is kind of thinking more about how to pull that data in and use it in unified ways to kind of systematically answer questions across jurisdictions.
Thank you. We have another question here.
Yes. Hi. As with schematics, I actually have two questions. Sorry, I said that we are allowed now to make one. So
we'll see how that scales.
yeah, they're completely different also. So the first one was I was very interested in what you mentioned, Regan, about the human involvement in the generation of machine learning models as a success factor. I think we all agree here that when you create a machine learning model, you do need humans to analyze the outcomes and then revert back to the model to make sure if the outcomes match with the observations, and then correct or tweak parameters in the model. But once that a machine learning model is considered valid, okay, and then you keep it running. And then I am linking here with a question that Jeremy asked yesterday night over beers. Said, okay, you have a model that works with this data, but then imagine that the data changes, okay? And machine learning models by nature, they are adaptable. They can learn from new data. But what happens if the data changes so extremely? And with weather, with climate, we're seeing more and more observations of extreme occurrences that have never been observed before. So your model that worked with the old data is not valid anymore with this new set of data, or maybe the geographical scope changes completely. So the model starts to diverge. Now, about the maintainability of the model, what do you think about human involvement in the maintainability of the model versus putting more effort initially into making a model more adaptable automatically? And then my second question is...
I think let's answer that question.
All right, okay, perfect.
All right, so I have a lot of on that. I mean, one of kind of our dream infrastructure would be to build this dynamic modeling system where we create our maps of probabilities of where people, where you're likely to find something. People go out, collect more data that feeds back into the process, and the models get better and better over time. That sounds fantastic in theory. Then you put even the first iteration of the models in front of people and they say, well, for the salamander, this really worked, but for this other species, this didn't. And if you tweak this and you get into that human mediated component that makes the outcomes better on like a per object basis, but is hard to build into a dynamic, updatable, consistent system. So there's a balance, right, between tweaking the computing to optimize your outputs and tapping into that human knowledge that's a little bit more variable. And so that's something we're thinking about a lot is, can you use the input you receive in initial iterations to figure out systematically what's going wrong and update your methods to address it? Or do you somehow need to structure your data so you're pulling in both measurements and human input and somehow develop algorithms that can kind of balance the two and adapt over time? So there's not a solution, but I think if anything from the big project that I've been engaged in this past year is we've really seen that the human knowledge is invaluable, and that without it, we could produce valuable maps for the country, but they would essentially be meaningless and not addressing the question. So it's something we need to figure out how to do.
I think we have an additional point here on that. So talked about it briefly yesterday as well. Like one of the things to keep in mind is this is something that the newer machine learning frameworks, mostly based on deep learning, have built in. They talk about machine learning pipelines. There are built-in checks to say, hey, keep running the test thing on the when new data comes in, run and check a prediction again, and if it's beyond a certain threshold, trigger the retraining based on the new data. But once again, I'm not saying it's going to work for every kind of model, right? And what we decided in our thing is to just use a combination of deep learning for like specific parts of the model, not for the whole pipeline. So you'll be able to automate retraining specific parts of the model, but not the entire model. So if your variance comes from the individual pieces, you will get the retraining automatic. But once again, it only works if you're in the using something like AWS SageMaker or one of the in-house ones. I'm drawing a blank on names, but there are frameworks that do that now.
For us, it's very simple. No model should go without being paired with a calibrated eyeball. Right? And this is where people can get confused. I think at times, too often people read into machine learning as human replacement, when in reality it's a force multiplier. I can do now with one what I could do with 100 before. And if we don't take that calibrated eyeball test, that does this make sense test, and evaluate the results, evaluate the output. Look, no one knows, in my case, no one knows their field better than the guy that's been farming it. His dad's been farming it. His grandfather was farming it for the last 100 years. So when I put something in front of him, he's going to be able to tell me if it makes sense. We might not know why yet, but he's going to tell me that there's a level of fidelity there. And I think that's the truth. This is the way that we conducted human terrain analysis. This is the way that we conducted human intelligence analysis. And there's, at this point, I don't believe it's responsible to remove that human element.
I'm sorry, I think there's more things to add in this. On to the next question.
So Todd asked a question from a financial investment perspective. I would ask the same question from an intellectual investment perspective about hyperspectral, because many of us are struggling with, we see the potential and we have certain visions what one could do with it, and then you just don't find the data, or they're just not the quality, or they don't come at the right temporal frequency. So I'm really interested in that question.
Yeah, it's particularly around the ag industry, and I'm happy to talk to you about it afterwards. We've done significant testing. I've spent a lot of money testing hyperspectral data on our research fields across our research partner programs. And the reality is, I think at the moment, the data is fantastic, and we know it is. But we have to ask ourselves, is the industry ready for it? Is the equipment ready for it? Are the chemistries to pair along with the decisions from it ready for it? And right now, it's not. And so it's a decision about, do I get ahead of the curve or do I not? And so I think in the spirit of keeping the rest of the conversation alive, I'm happy to talk to you guys afterwards and fill you in on what we've found and what our thoughts are there.
One last question.
Question for Edward. Given the position that DOT has, and in relation to HD mapping specifically, and the fact that we're all having this conversation within the umbrella of OGC, what are your thoughts in terms of standardizing HD maps itself? That as contrasted with today's mapping system, which I'll just call it as SD map, standard definition. Being these are just layers of information. Today, this piece of information is used for driving autonomous vehicles, going from level 1 to level 4 and so on, right? But I think in the larger context of data science, collecting the data, doing analysis, and all of that, it's super valuable, as you know, from a DOT perspective, trying to solve transportation problems, safety problems, and so on. But there's more to it than that. So any thoughts in terms of where we are in trying to push this as a standard, that the data collectors, everyone who's trying to build these autonomous vehicles can give that data in a format that can be understood by not just the cities, but software in general and data scientists at large?
Good question, and I definitely think we're behind the 8 ball on this one, where we've spent a lot of time figuring out how autonomous vehicles can work and how connected vehicles can work, and done a lot of research and a lot of projects on that. But not really looked at the bigger policy and how this the non-technical pieces come together, and that is, we need to do that right now. And how that comes about, I'm not sure what form it is, but it's definitely the collaboration across the spaces there to get to something, and it's the ability to go up and down between levels, and also what type of standards are we talking about? We spent so much time on the communication standards on autonomous vehicles and connected vehicles. As we're looking at these, are these communication standards, or are these geospatial standards? And I think some of those basic conversations still need to happen, and can they both coexist in this environment?
I think from a national mapping agency perspective as well, for the UK at least, I think there's interesting questions also as to whether when we're talking about HD roads or whatever, we're just interested in that CAV market and so on. And there's still a way to go to find out what is a good spec between the different technologies for just doing the localization and piloting function itself. It's not kind of one map that each of these fleets would want at the moment. But then for us, as well as how does it serve other purposes as well, whether it's the IoT market or simply local authorities better maintaining their assets and so on as well. So I think there's a way to go to accumulate enough evidence as to what is a good product or standard in that space personally.
I would also say without a standard, I think we end up with a lot of sub-optimization there. Optimization for the individual user, but suboptimal from a systems level.
Unfortunately, I think we're going to have to stop the panel session per se, but that doesn't stop the discussion. We're going to move on to the more of a breakout session and a discussion session that I'll hand over to George to describe.
Let's transition to that. And I want to applaud. Let's applaud the panel, but don't leave yet. Well done. So we have until lunch the opportunity to continue the discussion in breakout groups. And so we've identified them by application areas, if you will, and you see them in front of you now. So insurance, we have Yuting, yes, and Ben Tuttle, both leaders in insurance. Oh, wow. There's risk out there somewhere, right? Yeah. Yeah, if you guys gather at that table or go outside, we'll get to the outside option in just a second. Transportation, Ed, is at a table. Maybe we'll put that right here or outside. Natural resources and ag. So Regan and Steve, where were you sitting? We need a table. Who wants to participate generally? And okay, let's put it on that corner table down there. I don't know, Antonio, if you're involved or not, but that'll be the natural resources and ag. And I think they want to go outside anyway. So natural resources and defense and intel. So Megan, you're on there along with David and Mark. So over here to kind of begin that discussion on defense and intel. And then Jeremy was going to lead up data sharing, and I added ethics to that just to make it interesting for you. And so you can either stay at... Did you ask me what the ethics? No, I did it right. So there are two options. One is to go to those tables. Well, start at those tables. And then if you collectively want to go outside, we have a Google map to show you where that's at with a 3D model that's just plain glorious.
Okay, so if you want to go outside, you can see this is the building we're in now. Hopefully quite obviously, this is the building we're in now. If you walk across this car park, which is the car park in that direction, you get to a path here, which is the Stevens Creek. If I zoom out, you'll see it. And it basically runs out to the bay out in this direction. Or you could walk over in the other direction. It goes out towards the Ames Research Center, and you can see some of that's the wind tunnel and all the NASA stuff. I would go out towards the bay if I was you. Vice President Pence is visiting Ames today, so there may well be Secret Service guys buzzing around in that direction. So if you want to go for a walk, head off in that direction, out towards the bay. It is actually a nature reserve, so you might find some interesting things there. Amongst all the old bits of NASA hardware at the same time. If you are going for a walk, remember we do have lunch at 12 o'clock back in the cafe we used yesterday. If you're a little bit late, that's not a great issue. It's just going to be a bit busy, as you know from yesterday. But yeah, if you go for a walk, it's a bit cool out, but it's nice, bit of fresh air, and you'll get to see the neighborhood.
And elect somebody to report out. That's what we do when we get back at 1 o'clock, is each group report out. So, and preferably, quite frankly, people that haven't already been on the stage, if you will. So nominate somebody, or recruit somebody else to be the voice. Ready? Break.
Ed, where are you keeping those things?
Here, thank you very much.